more fun with factoring. This is a binomial, so of course none of our factor a trinomial tricks are going to apply. But it is a difference of squares because both of its components have nice square roots and there's a minus in the middle. So two sets of brackets, plus and then minus. The square root of k to the fourth is k squared. The square root of 1 is 1. Good. But that isn't the finished answer. Do you see why not? The catch is, this is also a difference of squares. We've revealed another layer doing this. So our k squared plus 1 just sits there. This isn't a difference of squares because it has a plus in it, of course. But the k squared minus 1, we can split up. Plus and minus. K squared would have come from k times k. 1 would have come from 1 times 1. Now it's completely factored. So it's just reinforcing the lesson that when you get to the end of a factoring problem, or what you think is the end, check each piece one last time. Just say, okay, can I break this down any further? K squared plus 1, no. K squared minus 1, yes. What are they up to here? Not a difference of squares because 80 doesn't have a nice square root. But what should we be looking for even before that? This has a common factor of 5. If you take out the common factor of 5, you're left with 16a to the fourth minus x to the fourth. This is a difference of squares. It comes apart as, let's see, plus, minus. 16a to the fourth would come from 4a squared. X to the fourth would have come from x squared times x squared. And now they pulled the same trick again. This also has is a difference of squares. Those both have nice square roots. So we get 5 times 4a squared plus x squared. And for these last two terms, 4a squared would have come from 2a. Oops, I forgot my plus and minus. 2 a's would have made this, and the x squared would have come from x times x. Okay, so common factors, and check everything one last time just to make sure that there isn't another step waiting for you. C, what have they got for us now? Well, common factor, definitely. Both of these are even, so we can take out a 2. This term has a p, so we can also take out 1p. So with the 2p pulled out, we are left with 2 divided by 2 is just gone. P to the fifth divided by p leaves p to the fourth. Then we'll have q to the fourth minus 162 divided by 2 is 81. P divided by p cancels out, and t to the fourth. There we go. Good start, but now, you guessed it, this is a difference of squares. So to factor that, we need 2 sets of brackets with a plus and a minus. P to the fourth, q to the fourth would have come from p squared, q squared, times, same thing again. 81t to the fourth would have come from 9t squared and 9t squared. And it's not even surprising by now because they've pulled the same trick twice in a row, 3 times now. This is another difference of squares. I'm going to write it down here because I need more space. 2p. Then we have p squared, q squared, plus 9t squared. We can't do anything with this one because it contains a plus. It's not a difference of squares, it's a sum of squares. But this breaks up. So 2 sets of brackets. This one gets a plus, this one gets a minus. P squared, q squared would have come from pq times pq. 9t squared would have come from 3t times 3t. Finally done. So the lesson from all of these is look for common factors and be persistent. Once you've got the thing, once you find something and you're able to break it down a bit, look at the resulting pieces and look at them with a fresh eye, if you will. Say, is there anything more I can do with this piece? Is it a difference of squares? Is it a trinomial? And only if the answer is no to all of those can you know that you're finally done.